All right, this is going to be the last video for Notes 23, and this is the newest concept, and we are going to solve using something called elimination. Now, the first video I did for Notes 23 was solving with substitution, and in those problems, one of your two equations said either x equals or y equals. And you'll notice we don't have that for problem number 5, or number 6, or number 7. So instead, we want to do elimination. Elimination is a descriptive term. Okay, it's literally telling you what you're going to do. You're going to eliminate either x or y. In our case for this problem, I am likely going to eliminate x, not necessarily y. Now, you could eliminate either. What you want to do is create a situation where you have one of your variables, either x or y, that has the same number, but one of your equations has a positive value and one of your equations has a negative value. So for example, in this problem, I can already see that this bottom equation has a positive 2x. Lovely. What I would like to see is this top equation then have a negative 2x. Well, let's just say I make it negative 2x. I can do that if I look to see, okay, to get from x to negative 2x, I had to take x times negative 2. Well, if I do that to the entire equation, I'm good. I can do that. All right. It's the same way when we divide an equation, right? Both sides of the equation by something. We add both sides to something. We can multiply as well. So I'm going to multiply that top equation through by negative 2. So negative 2 times x, negative 2x, negative 10y, and negative 2 times negative 17 is negative 34. All right. Now, if I've done this correctly, when I add this original equation, this 2x minus 4y equals negative 8, and this equation I created, one of my variables should eliminate. Oh, look, 2x plus negative 2x does exactly what elimination should do, which is eliminate a variable. Now, for the rest of the problem, I still need to add up. So negative 4y plus negative 10y is going to be negative 14y. I'm adding negatives to make a bigger negative. Speaking of bigger negatives, negative 8 plus negative 34 is going to be negative 42. I'm going to go ahead and divide both sides by negative 14. Wow, that was horrible. Let's try that again. There's negative 14. And that's going to be y is equal to, I believe, 3. Okay, so my system here, I've got an ordered pair. I now know that y is 3. Now, just like with substitution, when you're solving a system, you're looking for that point, right, that ordered pair, where these two equations are both true. Visually, it's where they would intersect. So now that I know what y is, I want to figure out what x equals. Unlike, well, actually, no, like substitution, does it matter which equation you use? Absolutely not. It's just whichever one you see as being easier. For me, I'm going to go ahead and grab, I don't know, the top equation here. I guess the reason would be it's all positive and x is just x. That seems like a good enough reason for me. So off to the side here, we've got x plus 5, y is 3. So I'll go ahead and do that substitution, and then equals 17. So solving this, I'm going to get x plus 15 equals 17. Subtract 15 from both sides, and I'm going to get x is equal to 2. Okay, so if I wanted to, I can take these two values, plug them both in to make sure they work. Now, I'm pretty sure it works in the top equation because that's what I just solved, but just for giggles, right? X is 2. 5 times my y value is 3 is 15, so 2 plus 15, absolutely 17. Bottom equation here, be careful, I know I crossed this one out, but I can still read it. It says 2x, so 2 times 2 is 4. Negative 4 times 3, so that's negative 12. So 4 minus 12 is absolutely negative 8. You don't have to double check. That's something I just do to make sure that I didn't screw anything up. Especially with these videos, I don't want them to be inaccurate. So yes, that is the correct answer for problem number 5 using elimination. All right, I'm going to slide on over to number 6, and I'm going to do the same thing. Now, do I want to eliminate x or y? This one is really a toss-up. You could eliminate x, right? We've got 2x here. I could pretty easily make this bottom equation have a negative 2x. I would just multiply through by negative 2. For y, I'm actually going to stick with y, I think, for this one. My bottom equation is 2y. My top equation, hey, it doesn't have negative 2y, but it does have the negative. I kind of like that. So I'm going to go ahead and apparently shrink the screen there. I'm going to take the top equation times the negative 2. Speak English and slower. Just times 2. Okay, so that would be 4x minus 2y equals 14. So if I've done it correctly, which I think I have, when I add this, one of my variables should eliminate. So x plus 4x makes 5x. I've got 2y here plus negative 2y. There's my elimination. See, I knew I had it. And then 6 plus 14 makes 20. All right, divide both sides by 5. X is equal to 4. Okay, so ordered pair here. I know what x is. Okay, great. And just like the last problem, I still need to figure out what y is equal to. Does it matter which equation you plug into? Absolutely not. It really does not. I'm going to go ahead and grab the bottom equation because it's all positive. Sure, why not? Seems like a good enough reason. It really doesn't matter what your reason is. It's whichever one you decide you want to work with. And I wrote down x and I realized I already know what x is. There we go. So 4 plus 2y is equal to 6. Okay, so let me double check I didn't screw that up because I already look like it. Okay, no, we're good. All right, so now solving this, I'm going to go ahead and subtract 4 from both sides. So 2y is equal to 2, dividing both sides by 2, and I'm getting y is equal to a lovely 1 there. Keep shrinking the board a little bit. Okay, and again, just to make sure I haven't done anything horribly wrong, let's go ahead and put 4 and 1 back into the equations just to double check. So 4 for x, so 2 times 4 is 8. Y is 1. 8 minus 1 is absolutely 7. Bottom equation, 4 plus 2 times 1, so 4 plus 2 makes 6. Yep, we're good. All right, there is my fabulous ordered pair for that one. That is the point. If I were to graph these two equations, this is the point where they intersect. All right, last one, solve number 7. So we've got another system. Could I eliminate x? Yes. Do I want to eliminate x? Let me take a look at y first. No, I don't want to eliminate x. It is going to be so much easier for me to do a rewrite on this one. Now, because of the nature of the fact that I'm changing the bottom equation this time, I am going to take a step here and just rewrite the top equation so I can go ahead and stack these up. All right, bottom equation. This is a negative 3y, so I want to turn this into a positive 3y, which means I'm going to be multiplying by a negative 3, okay? Because we already have a negative in front of the y, the negative times the negative is what I want. All right, so there's negative 21x. We've got positive 3y equals positive 15. Yep, make sure all those are good. Okay, they are. So now I'm going to, of course, add those together. So 5x plus negative 21x is going to be negative 16x. Negative 3y plus positive 3y, that's going to cancel or eliminate, right? The elimination method. Descriptive, folks. All right, 1 plus 15 is 16. Divide by negative 16 on both sides. And I'm going to get x is equal to negative 1. All right, so there's my negative. Wow, none of that wrote. Okay, there's the negative 1. And then I need to figure out what y is equal to. Top equation, bottom, it doesn't matter which one you use. I'll use the top equation. I don't know. The numbers are slightly smaller? Sure, we'll go with that reason. All right, so 5 times x is negative 1. And then minus 3y equals 1. All right, let's see what we can get when we solve this. Let's see, negative 5 minus 3y equals 1. I'm going to add 5 to both sides. So negative 3y equals 6. Divide both sides by negative 3. I'm getting y equals negative 2. All right. Now I got to pay attention to my negative signs. All right, so doing a quick double check here. 5 times -1, that would be -5. 3 times negative 3 times -2 is 6. So -5 plus 6 is absolutely positive 1. Let's see, that would be -7. So if I place, yep, that's -7. And then -2 would be positive 2. So -7 plus 2 is absolutely -5. All right, I did not screw any of this up, other than every once in a while stumbling over my own words. All right, that is the end of Notes 23. I broke it up into a whole bunch of different videos so that they weren't too terribly long, hopefully. As always, if you have questions or concerns, please reach out to me and let me know how I can help you. Other than that, I'll see you in the next one. Take care. Be well.